From the Library of Congress in Washington, D.C.
Hi. So next we have a panel on research data and creation. We're going to have a couple of curation. What did I say? Curation. We're going to have two presentations and then some time for discussion. First up, we have Ina Cooper, who's a research scientist from Indiana University, and Dharma Ackman, who's manager of education and outreach for the SEED project, which is based at the University of Michigan. Following their presentation, we're going to have Ishelle Faniel, who's associate research scientist at OCLC Research. Looks like we're all mic'd up. Okay. Ina, Dharma.
We're going to be switching back and forth in our presentation. A little bit of background to begin with. We work on a SEED project, Sustainable Environment Actionable Data, which is an NSF-funded DataNet project that works on building tools and services that support data creation and data preservation for sustainability science. There are quite a few people working on the project, and nothing could happen without their effort, obviously. So one of the things that we face working on data curation, supporting data curation, is that there are a lot of challenges. And yesterday and today there were conversations about data already, and I think pretty much everything that is on this slide was already covered. All these challenges that research can go on, it can be short, it can be long, it can span over the years. The data, it's not something that is homogeneous, and it can be very complex. Usually we don't deal with files, we deal with collections. They can be mini collections, but they can be huge collections. They can be of various sizes. Data goes through multiple stages, and again, going back to the research life cycle and the beginning of data collection and then the end, which might be publication but might be something else, it's important to keep in mind that there are multiple stages. Work that happens with data, it involves a lot of different processes, including analysis, but other processes as well. And we're working not with just products, but other activities that go on while processing the data. There are many different kinds of agents that work on data, and all of it sort of involves nonlinear relationships. And this is what we try to capture and formalize, because when building infrastructure or tools, we need to think sort of ahead, and we need to think in advance of what we're going to do, because once you start building, it may not work as you thought it would. So to address these challenges, this is something that we work on. The framework that we develop, we build upon the work of others, primarily David DeRuhr and Carol Goebel, who this idea that data and research products are not just single objects, but they are bundles, and you need to keep them as bundles. It came up in the computational sciences a lot, and people realize that also it's not just data sets or files that you work with, it's scripts, software, and all these different types of objects that we deal with. So the research objects framework, we try to capture these multiple aspects of working with data, and primarily it has these 5 components that it needs to be identifiable, obviously. We need to track it through the life cycle. It has content, and but this is one of the aspects that we're dealing with when preserving these kinds of objects. Agents that need to be conceptualized as different types of agents, and we deal with data creators, curators, and data reuse scientists, as each of them having different types of activities that need to be captured as they work with data. relationships, as I mentioned, the research objects are bundles and they go together. It's important to capture different types of relationships. We began with sort of a set of simple relationships, and these are the bundles are aggregated, right? So there is a relationship of aggregation. Entities within the bundles are related to each other. So there is a related to relationship. Each entity can be described, and the bundle itself can be described. So there's a description relationship, but also the versioning and derivation are very important types of relationship that you need to be working with when we talk about data, because of this reuse aspect of it particularly. And data keep changing. Once something is stabilized, if we're going to support reproducibility especially and reuse in the future, this is something that we need to be keeping in mind. And as I mentioned, research objects go through different stages, or they change states, and we work with the whole research life cycle and trying to capture whatever is going on with data from the beginning to the end, or the cycle when it goes back. So we conceptualize the states of research objects as being live, being curated, and being published. And I'm going to let Dharma talk about the life objects.
Okay. So one of the central concepts that we deal with is the fact that we're dealing with active curation, which means, as Ina alluded to, that curation activities are happening from the beginning of the object's life cycle. It's not just something that happens when it gets passed off to a repository, but it's happening as early as when the scientists start gathering the data and start working with it themselves. So we have sort of the research object existing in or going through three main states: live objects, curation objects, and publication objects. And there's a few important characteristics and allowances of each of these states that we'd like to highlight. So live objects are mutable objects that are in a state of flux. They can be changed, they are not a static, immutable thing. They include collections of data and metadata that the scientists are actively building, editing, and transforming as they work. They're mostly handled by a project team, so it's a team of scientists that are working with the data. So for example, we have a group called the Mississippi Flood Project. A small team of scientists are the ones that are adding the metadata, adding data, adding different derived products to the object. I'd like to highlight also that these practices are driven primarily by self-centered or project-centered needs. So the things that they're doing are meant to facilitate their own use and management of the data for their own sort of immediate work. Many scientists are potentially involved in adding metadata. So it's not just one person is in charge of one object, but there's potentially a lot of different people that are contributing, editing, and transforming the object. So when a team decides that a research object, a live object in this case, is ready for publication, they can initiate a process whereby it goes through this intermediate state and then it becomes a publication object. So the next type of object or object state I'd like to talk about is the curation objects. So when they initiate the publication, as I said, it sort of goes into this intermediate phase. The content of the object is packaged using Bagot protocol, which stores a bag of the content data, in this case, and the metadata so that it supports the object's storage and transfer. And then we also use the OAI ORE to map the metadata and its relationships. At this point, the primary person dealing with the object is a designated repository curator. And it is somewhat mutable. The metadata can be changed if it needs to be made better for long-term preservation, but the object itself isn't really changed. The data themselves aren't changed. Once the curation object is sort of complete, it's undergone the professional curation, if you will, it goes into a publication object. And this is an object that is now immutable. The object itself is assigned a persistent identifier, a DOI, so that it's citable. as I said, it's no longer this object that can be in flux and be changed. It's deposited with one of our partner repositories, and we do track things like revisions, its lineage in terms of revisions. So if a team found that something was wrong with the data, we would track that there were several revisions of this object, and derivations, because one of the concepts behind our project is that we want people to be able to take the published objects, move them back into, I shouldn't say move them, but maybe take a copy of that published object and then have it be a live object in the system. Then it becomes sort of a new thing, but that relationship would be tracked. So Ina and I are both going to kind of talk about what it means to work with these different objects in SEED. And I'm going to hit upon the live object. So this is an example of live object in project space. So teams of scientists work with the live objects in a space that they control. They can choose who has access. They can upload virtually any kind of data and add almost whatever metadata that they want. So what we see here is a screenshot of a data set with its information page. You can see many different metadata fields here. SEED, we don't impose any metadata. They can add as little or as much as they want. They can choose the controlled vocabulary if they want to use it. So just some examples to call out. They can add license information about copyright. They can add the data's maturity, so they can say if it's raw or heavily derived. They can add a number of different Dublin core-oriented fields, such as contact information, abstract, location information. We also extract whatever metadata that we can from the file, so things about the image size, where it was created. If the device that they use to create the data has some metadata package in it, we extract all of that. So I guess one thing to highlight, I already said this, but I think it's important to say again, is that this can be incremental. It's not just that they upload the data and then they're adding all the metadata all at once necessarily. This is something that can happen over time with many different people who are involved. So when the team is done with the data collection, meaning that they think it's ready to be released, they're ready to have it more available to the public, and they want to publish and preserve the data, they can mark it as ready for publication, and this begins a process that leads into the curation and published object, and Ina is going to talk more about that.
So the idea is that, and there's another screenshot of how the system works. The idea is that the system should facilitate the work of these different types of agents, right? And the scientists or researchers can do what they need to do, and they're not constrained by these concepts or ideas of a particular metadata scheme or a particular approach. But then we all realize that it's important to provide curation and preservation kind of activities that enhance upon the research object that's been created, or if there is a need to do that. So then the curation step is to facilitate other types of professionals working with the data, rearranging if necessary, adding metadata and other types of things, and then making sure that it's ready for long-term preservation. And then the object goes into a repository, and this is what we mean by publishing, right? It goes into this immutable state. So I want to conclude by referring to these broader implications. The research framework that we use, it's kind of independent of standards or particular approaches, and it allows us to conceptualize things that later on we could employ different kinds of protocols, like we use Baggett and ORE now, but it can change in the future, and our understanding, our conceptual approach allows us to do that. We're not tied by that. But the importance of the research object concept is that it allows us to think about how to capture content, context, processes, and states, and thinking about it all together in a systematic way. We acknowledge that entities can be edited on multiple levels, and that's what we're trying to support. Again, like I said, these bundles, they can be very complex and very heterogeneous, and then you need to think about it not just in terms of formats, but thinking about different aspects of these entities. We also recognize that the way we deposit things for long-term preservation can change, and it's not, right now institutional repositories might be one of the most viable options. Cloud storage or domain repositories can come later. So we're using a matchmaking mechanism to determine these best approaches to where the research objects should go. Definitely, it's a work in progress, and a lot can be done. There is the ownership of research objects is very complex, so there's a need to support multiple licensing and multiple permissions. Lineage tracking, like I said, the reuse framework is a crucial component of the current data landscape, and it's really important to track lineage. But it's not just to track who revised or created a new object, it's also to build tools that facilitate trust, authority, and authenticity of these data sets, which is a very complicated problem. And because we're focusing on this reuse framework, it's, we're looking for more cases of reuse, because the more cases we have, the more details we get. And with every case, pretty much we'll learn the new complexities and the new challenges that we have to deal with, and this helps to expand the framework and to improve it and to make it more usable. Thank you.
So we'll do questions at the end of Michelle's presentation, and hopefully have a discussion. Yeah.
I'm just going to set up my timer so I know where I am. So my name is Michelle, and today I'm going to talk about three perspectives on data reuse. So that of the data producers, the data curators, and the data reusers. So this project is being done in collaboration with Elizabeth Yackel, who unfortunately could not be here today. So I'm going to try to do the presentation justice. So one of the three perspectives that we're looking at comes from the archaeological discipline. So a little bit about archaeology in terms of its practice, what's going on in terms of changes, trends, and traditions. So there's a changing nature of the research questions, from in-depth focus on a single site to analysis of social, cultural, and economic trends across multiple sites, which leads to the need for more data. And when we're looking at collecting data across multiple sites, typically archaeologists can't do that in their single career. So data sharing, there's increased pressures around sharing data amongst the community. We also have the fact that more and more archaeologists are no longer able to remove artifacts from the country of origin. So that means that documentation and documenting over the time of the excavation of the survey has become much more important in terms of archaeological work. And then we talk about the data reuse tradition. So typically there's been substantial use of museum objects, and those objects are used as comparanda to try to identify newly found objects. Typically there's been little sharing in the community in terms of research data. When it does happen, it happens on a person-to-person, one-on-one basis. There are currently a couple of archaeological repositories out there, but again, there are still repositories that are relatively young. So in this project, we're examining, as I said, data reuse from three perspectives. So the perspective of the data reuser, who's collecting and documenting that data and sharing it. The repository staff who are curating that data, so that includes processing, preservation, and dissemination. And then the data reusers. So those are folks who are conducting studies, and they're using other people's data to be able to answer these new research questions. And so what was our research question for this case study? We were really interested in how actions in one part of the data lifecycle create challenges or facilitate work at other points in that lifecycle. So this underlying case study examines zoo archaeologists, so archaeologists who examine animal bones. And so we're looking at the point at which that data was shared to the point at which that data was published, and published by a person who reused that data to answer a new research question. And so the research questions that they investigate have really centered on the types of animals exploited by a culture. So if we think about animal domestication, it can signal change from a hunting and gathering to an agricultural economy. And so the zoo archaeologists that we followed worked or collected data or contributed and reused data across 12 sites in Turkey. And these sites documented communities anywhere from 20,000 to 3,300 BC. So our research design, this data was collected over about a year and a half. We interviewed the data producers and reusers before and after their reuse experience. We analyzed email threads among the data producers and the reusers, and these were typically emails that were exchanged with repository staff. We conducted a focus group with the data reusers, and we observed presentations resulting from data reuse. So they all gathered at a conference and shared their analyses that they had done. And then it also resulted in a publication, so we had that publication as well. In terms of data analysis, it was qualitative. We did coding, and we basically expanded our interview protocol and code book from previous work on another project that we're collaborating on called Dipper. So there we're also looking at reuse among data reuse in academic communities. And so 2 coders coded this data set, and they worked closely together to ensure consistency in coding. So in terms of our findings, really they do demonstrate that there are these interdependencies between different parts of the data lifecycle. And the actions taken in one part really do have an influence on things that occur in other stages. So broadly speaking, in terms of our findings, we found that repository actions are overwhelmingly positive, but they can't always reverse or explain data collection and documentation procedures. We also found ways in which factors related to data sharing affect repositories and reusers, and how acts of reuse can influence repository policy and data producers' later actions. And so I'll go into each of these in a bit more detail to give you a flavor about what we found. And as I said, the good news here is that repository staff can facilitate data sharing and data reuse, and they do this in a number of ways. In this case, one of those ways was standardization, or decoding or aligning diverse codes that producers used for these animal bones and teeth in this instance of this case study. And then it was integrating that data from different sources. So as the data reuser 9 says, integrating it to the extent it was comprehensible. Because in terms of zoo archaeologists and the way they work, they do things in a number of different ways because they come from different traditions. And so these kinds of things not only facilitated data reuse, but they saved time and effort in terms of the data producer who was sharing that data and preparing that data for sharing. As noted in the last quote, the repository staff did a lot of cleaning. And that a data producer can do, but it would take a lot of time to do. So in terms of repositories not being able to reverse certain things in terms of the data up front in that life cycle, in terms of collection and documentation, there are limits. So one thing that came up is this idea of sampling procedures and those things and how those things influence data reuse. So these really need to be identified for reusers down the line. So the researcher here sampled goat and antelope bones, but not necessarily other kinds of bones. So cow bones or data, or pig data. And it was necessary for the repository to be able to add attributes, or what people call a dummy variable, to indicate whether or not things were sampled. And it's important because if a data producer only samples one type of bone at a site, it kind of it limits the kinds of analyses a data reuser can do. So for instance, this person talks about being able to calculate the number of identified and number of individual specimens for the total site. Well, if someone's only sampling one kind of bone, the reuser needs to know that, because then they can't do that kind of calculation. The other issue that came up is underspecified standards and how that impacted both repository staff and data reusers. And it concerned teeth and being able to categorize wear erosion in teeth. And so there's a person by the name of Payne that developed a system to identify the amount of tooth wear, and that's widely used in archaeology. And the stages are well described, but there aren't really guidelines in terms of how to document those. So it could be that you're identifying tooth wear and doing it for the whole specimen. Sometimes people identified it at the level of the individual teeth. When they coded that kind of data, they could code it in terms of one column in a spreadsheet or 4 columns. There really weren't guidelines on that, and that caused issues down the line. When we think about different kinds of data sharing factors that influence repositories, 2 that came up were data format and data condition. So data transformation from one system to and one data format we found caused multiple issues. So the quotation that you see here in terms of data format is really the beginning of a long back and forth between a data producer and repository staff in trying to understand what's going on. And so it turns out the format was a FileMaker Pro, and that needed to be changed or transformed into Excel. And what happened during that transformation is that entire records of bones had been duplicated in that effort, and that certain things mapped to the wrong columns. And it took several days of data processing and integrity checks to try to unravel all of that and fix it. In terms of data condition, it's really what form that data comes in to the repository. So there's an example in terms of repository time and how long data processing takes. And so there was one data set that was coded, and that data set contained 20,000 bones. That took 10 times longer to process than a data set that had 100,000 bones that had been decoded. So the condition in which that data comes in is critical in terms of time and processing. Data sharing factors that influence data reuse. Data selection is key for reuse. And data producers, we found, withheld different fields in order to submit what they thought was a more coherent data set. So things that were typically taken out were notes fields. They were identified as candidates for deletion before sharing. And so the above quotation illustrates one data producer talking about and discussing his concerns with sharing his own notes. He eventually did it, but there was another producer who actually eliminated her notes entirely from the data set. She just changed her code, she said, and then she sent that off, and she deleted all of her comments because you can't quantify those. There wasn't anything really essential there, she said, so I deleted them. So the repository staff, this all came out during our focus group interviews, and repository staff actually expressed surprise that this came out in terms of the focus group. But it also demonstrates that context can be omitted, right, without the repository staff or the reusers actually being aware that it ever existed. In terms of data reuse, and that how that might influence future actions of the repository staff and data producers. Many of our participants had shared data before. This group actually knew each other and knew each other's work. So they shared it with one another, they shared it with other archaeologists. But that sharing and reuse typically occurred on that one-on-one basis. And it was more limited. This data reuse experience really opened their eyes to the interconnectedness of the life cycle. And it made both the repository and the data reusers consider their practices. It kind of gave them like this 360-degree view of what happens, and some explanation in terms of why in some cases. So for the repository staff, they found that their dissemination format that they used caused problems for data reusers. So they began to think about ways in which they might be able to change that or offer tips in terms of how to use the particular format. In this case, it was CSV. Data reusers reflected on their own documentation practices as well and thought about how they might document in the future. So one talked about using the common standard for tooth measurement. Another talked about being more specific and actually writing down all of the criteria that he used when he was sampling things, when he was deciding bone fusion, when he was deciding tooth wear, and maybe just dropping numeric codes altogether and just starting to write everything out and keeping it in that way. So what does that mean in terms of implications of this study? So the data life cycle is by nature tightly coupled. It's a tightly coupled system, right? What happens in one part of the life cycle affects another, and we've seen this in the case study. That's kind of what we went in thinking, and we were able to see this in the case study. And in contrast, when we think about data producers and data management activities, that they perform, those are really loosely coupled. And by that we mean their activities are siloed. They don't think much about other uses or other users of their data. For the data reusers in this project, many began to see, as I said, because they were involved in this project, connections between the different activities. And I think it's important to note that a lot of these reusers were also producers, so they were also sharing their data. So it was kind of this collaborative effort. And meeting at that conference and discussing their data analysis and what they found and some of the issues they ran into in reusing the data is really some of the things that kind of opened their eyes to this process. It allowed them to more readily feel and hear what was going on in terms of sharing and reuse. So when we think about other implications, particularly when we think about short and long-term benefits, some of these things came out in the panel yesterday. But there are these individual rewards that we can think about in terms of data reusers, the publication of the article by reusing someone else's data that results from that reuse. We can think about data producers and data archiving and data publication. We can think about repository staff and getting better data submitted. Right, but some of these, in terms of the individual rewards, are actually potential rewards, right? So it depends on that social infrastructure that Fran Berman talked about yesterday. And so that means questioning whether or not archiving and publishing your data are actually recognized and counted when you're going up for promotion and tenure. It depends in terms of reuse and whether or not data reuse is actually considered a respectable way to conduct research within your discipline. So without those things, some of these individual rewards or incentives may fall apart. And then we can also think about science and think about the larger community in terms of short and long-term benefits and gaining new knowledge, given the kinds of research that they're able to do. Other additional short and long-term benefits. For the entire designated community, is having this large data set available for reuse. It's also about increasing the visibility of new archaeological data sharing and data reuse practices, and what you gain from those, the kinds of questions that you can ask. They can now look at the publication and say, wow, they were able to do this kind of work, given the fact that they had access to this amount of data. And for the repository, there are these reputational effects. So this project brought together about 294,000 records of bones across 12 years, right? So this is one of the largest data sets of its type, and it's a demonstration of the successful working together of repository staff, data producers, and data reusers. And so with that, I'll just acknowledge folks that helped on this in terms of doctoral students, Rebecca Frank and Adam Kreisberg, and Anthea Josias, as well as our study participants. And I think we're going to open it up to questions for everyone. So.
Thank you. Does anybody have any questions first off for any of the panelists? Questions? No? Well, I can ask a question. So you all talked about users and the content producers. So there have been a lot of questions about how sort of the preservation community can interact with content producers, and you guys just talked about different strategies. And I wonder if maybe you could each talk about what you've learned in your projects that could maybe help people in other fields thinking about how to interact and build systems for content creators that makes it easier to preserve the things that they're creating.
So I think for the project that I worked on, it was the fact that they were actually able to share and reuse data for a real project. So the zoo archaeologists were pretty stoked that they had access to 294,000 bones, right? And so they were willing to do the work to get access to those 294,000 bones. And I think it's those kinds of real world projects. I think someone on a panel yesterday talked about the need for the preservation folks and library folks to get hands-on experience with it. And this is the kind of hands-on experience, I think, that would kind of move everyone forward. So librarians and preservationists are really seeing the dirty kind of things that you need, you know, the real nitty-gritty detail and things that need to get done. And in the end, you're going to have producers and reusers that are going to be like, wow, now we have access to this data.
For us, I think it's really about making sure that the data creators are getting some kind of value added to uploading and adding metadata to their data. So we try to offer services that go beyond what they can currently do. So for instance, it has added functionality that are created for data that's better than Dropbox. They can preview their data right in a browser. They can add different metadata fields. They can set their own kind of schema based on like what works for them. If they want to use EML, they can do that. And so it's about really adding something that makes it easier for them to do their work as they're creating the data. And so that way, what's an active project space to them is sort of a staging area for the data curation and preservation. I don't know.
Any other questions? Okay, we got a couple over here. I think we got mics, so we can, so everybody can hear. If you keep your hand raised so Mary can see you.
Hi, what was your methodology for deciding on the data model for disciplines that don't necessarily have one standard way of dealing with their data, like non-standardized disciplines, like archaeology and a lot of the life sciences?
So is that a question? Oh,
Is it a question
I didn't get
to the whole panel, yeah.
Do you want to go first with your model?
Right. Well, as I said, the research object model is sort of agnostic. We do work with sustainability science, but sustainability science is a very broad notion, and it can include many different kinds of sciences, from hydrology to ecology to sociology. So, we are sort of agnostic to these particular models and particular approaches, and trying to be flexible and incorporate different kinds of models that people can work with.
I think for archaeology, and I can't speak because I'm not on the repository staff, so I think if Eric Consa was here, he would give you a much better answer than I'm going to give you. But I mean, I think in this particular instance, they were really only working with the zoo archaeologists, and they started with them because they kind of had some kind of standard ways of describing their bones initially. I mean, and then he relied on different kinds of ontologies as well, and controlled vocabularies in terms of being able to integrate the data from the different zoo archaeologists. And he actually talked with, I think it was EOL and Uberon. He actually had conversations with them to kind of add things. So for zoo archaeologists, they need to call something a sheep goat because they don't know if it's either or yet. And that wasn't something that was in that standard. So it was also kind of talking about, can we add this? And having conversations with people about these kinds of things that come up when you're actually kind of in the throes of doing it. So I know that's probably not the best answer, but that's what I'm going to stick with today, since I'm not on the staff necessarily. But those are just some of the things that I know they had to deal with specifically.
Well, another thing that is sort of to add to that is we're trying to support the distinction between keywords and controlled vocabulary terms. So if people, whatever you want to add in terms of keywords or tags, please do. And that's what we're trying to support and encourage on the active curation side, when some researchers may not care about particular subject headings or controlled vocabularies, but then the curator stage, where it is important, and there are in certain disciplines certain controlled vocabularies that can be used, that will be added, and both of these types of terms will be preserved and can be used in search and discovery.
Great. I think we had one other question back here. And I think this will have to be the last question, since we're...
Actually, it's two questions.
Okay.
I'm Carrie Devra, Title Center for Copyright Integrity. To the doctor on the end, I have a question about, You kicked off talking about repatriation of, or the difficulties archaeologists are having with removing items from countries. Are you finding that there's been a greater movement to repatriate items in collections back to their countries of origin? My second question is to the two ladies working together. You mentioned Dropbox. There's file sharing and downloading going on, and that's quite an issue out in the worlds of content ID, IP, rights of publicity, and rights of privacy. How are you protecting yourself as a community against someone coming up and putting a claim against you for usage?
I should mention they're all doctors. All of them.
Well, then we're covered. Is there a doctor in the house is answered,
Yeah.
sort of?
I guess the short answer to your question is I don't know the answer to that because I'm not an archaeologist. I think that's the trouble I get into, being a PhD in business administration, interested in technology and users, and I go to a whole bunch of different conferences and I study different disciplines. People think I'm an earthquake engineer and an archaeologist and a zooarchaeologist and an archivist, and I'm none of those. So I can't necessarily answer that question. I'm sorry.
And I'm not sure I understand the question, so you can tell me if I'm answering it correctly. I mean, we don't interface with Dropbox in any way. Yeah, for us, I mean, I think we're still working on the agreements, but it's, basically up to the people that work within a project space. We kind of leave it up to them to follow usage rights in terms of the data that they bring in. Mostly right now, it's teams are putting their own data, so I don't think there's a lot of transfer going on yet. I don't know if Inna can add to.
There's no emailing going on.
Yeah.
The components, the system components and the repositories interact via APIs, and whatever security protection is in place, that's what will be part of it.
Okay. So I think we're at time. So can we give the ladies a round of applause?
This has been a presentation of the Library of Congress. Visit us at loc.gov.